Hi, everyone. It's great to see a lot of familiar names in the chat. And yeah, I'm Marta. I'm the head of developer experience at Materialize, and our team is the owner of the dbt adapter. And we've just spent a lot of time thinking about how we can support existing dbt users that are adopting Materialize coming from a different database, but also how we can push the envelope into in relation to things dbt can only do if it's backed by a database like Materialize. I half assume everyone here is familiar with dbt, but I still wanted to drop a TLDR and a few links you can use to learn more about it if that's not the case. So dbt is a tool for managing data transformations in your data warehouse. The really cool thing about it is that it allows you to adopt best practices from software engineering while still mostly typing just SQL. And today we'll be focusing on one of those practices, which is CI/CD. And if you're here, it's also possible that most of the contact you've had with dbt before was in traditional ELT or ETL scenarios, which is natural because dbt was built for batch in the end. And hopefully this matches to a very simplistic level your mental model of things. So you have one, possibly many operational databases that handle transactional data, like for your customers, your orders, your payments, and periodically you run a batch job to kind of ingest all the raw data from those source systems into your cloud data warehouse. And it's there that you use dbt to just transform that data into something useful. And you might have some other system downstream consuming this data, like a BI tool that then lets you distribute that knowledge across your organization. But throughout this whole process, your end result will always only be as fresh as the last time you ran dbt. And good for us, as it turns out, if your database speaks SQL, dbt doesn't really care if you're running batch or streaming under the hood. But in contrast to the previous mental model, what you have now is you're able to use dbt, but still process changes as they happen instead of having an orchestrator that schedules some jobs on some cadence. And you still use SQL to define your transformations, but now you can skip a lot of this coordination and just have a database that efficiently keeps things up to date for you in the form of self-updating Materialize views. And this means that you can keep your downstream systems always fresh and not dependent on how frequent your dbt jobs run. But what brings us here today, though, is to dive a bit deeper into how dbt can help us make data deployments less hard, and hopefully realize that the workflows that you use with a streaming database like Materialize end up being the exact same as you would with any other of the databases that are supported by dbt. And because I do remember how I used to test SQL changes in production, it seems like it's still happening out there to a lot of the same extent that I remember, despite the evolution that has been going on in the ecosystem. And having an automated way to validate and test your changes doesn't really solve all the problems, but it's somewhere to start. So in this demo, I'm going to assume that you're using some sort of version control with your dbt project. I'm going to use GitHub and GitHub Actions in these examples, but it should transfer pretty cleanly to other platforms like GitLab or Bitbucket or whatever it is you're using on your end. So the first goal here is to lay out just a strawman workflow. And what we want to do with dbt in a CI/CD workflow is you want to be able to submit a change to your dbt project, or someone in your team submits a change to a dbt project. You have that change go through validation in a staging environment, or in multiple staging environments. And then you deploy that change to production once everything looks like it's good to go. And in practice, and like very overviewy, this is what it looks like. For like a basic CI/CD workflow, you have your project, your dbt project hosted on GitHub, for example. Someone opens a PR, and this PR will trigger a workflow that takes care of these three big things that I just mentioned. The first one being preparing the CI pipeline environment. So things like installing all the required dependencies and caching them so that in each run, you don't have to do all this work over and over again. One example is you have to install dbt, right? But not everyone is using the same Python dependency management framework. So this is one thing. And on the Materialize side, we also need to guarantee that we isolate each of these PRs from everything else that is happening in the database, because you don't want something accidentally bringing down your production environment because someone is running some crazy SQL model in staging. And then we can just unleash a dbt run against a staging environment. And all going well, what you want to do then is be able to merge the changes that you push into the repo. And this will then trigger a different workflow, which is the CD part of just like deploying the changes to production. And it goes through most of the same thing with the pipeline config, but now you want to make sure that the temporary environment you created in Materialize to isolate the work that you were doing, you want to make sure that it's spun down so that you don't have an idle environment just like eating away at your credits. And again, everything passing, the changes get deployed to production and your new model is live. As a side note, we shouldn't forget that if we close the PR, we also need to think about cleaning up the environment. So I just left it here because I think it's easy to miss, but if you close your PR, you should at least also just make sure that you clean up your Materialize environment. Cool, and this is an overview of the steps that I'm gonna go through. It gets a little complicated to follow, I imagine, from that side. It's hard for me to remember like what things I need to click and when. So this should be like a good overview of what's going to happen like in the next 5 minutes if you get lost. Cool. So I'm switching over to a short demo. I put together a repo that will eventually live not in my personal GitHub account, but in the Materialize organization. And as you can see, what this repo has is a dbt project, as you can see from like the dbt project.yaml and then like the profiles.yaml. And it also has my PyProject file, which has all the dependencies that kind of make up my actual environment for dbt. And you see here, we're pinning the version of dbt. And so like this makes sure that whatever dependencies you're pinning to in production, like anything that spins up one of these workflows for different environments should kind of like use the exact same dependencies that you have. So there are no surprises. Cool, and in our profiles.yaml, what this little file allows us is to tell dbt how to connect to Materialize. And here we have, because I'm grossly oversimplifying this demo, we just have two different environments. We have staging that is pointing at a database called db staging. Then we have production pointing at db production. And you will notice that in the production target, we are setting a cluster called quick start. And this is kind of like this precious box that I was talking about before of, the things that are running there should not be affected by whatever else we're going to run. And for the staging environment, because we want to spin environments up and down as people open and close PRs, we are going to go with a variable that will just spin up a new cluster when a PR opens, and it will prefix it with some GitHub stuff and then with the number of the pull request. And in reality, I should have done the exact same thing for the database. And it's probably when you transfer this into the real world, you will probably want to generate both a cluster and a database per PR. But I will include that after the demo. Cool. So let's just jump over to Materialize real quick. And I'm connecting to Materialize just using pSQL because it's PostgreSQL compatible. And we just want to make sure that both our databases exist. And you can see that they are here. And my first task is to just pick a model that I want to change. I just want to make like a small change to some model. And the model I'm going to make a change in is the least risky one, which is like the very last model in our dbt DAG. So I'll just open that up. If I find, okay. So I'll just edit a model to create just a change that I can push into the repo. I'll just edit out the item name in this model. And what I want to do now is go back to, this is our repo. I'm in a branch called test. And I didn't mean to like change all those models somehow, but I just want to add my Mart's item summary. I want to commit it to Git and say, remove item name. Mart model, and I want to push it to my test branch. And it should appear here that I can make a pull request. And as you can see, all I'm doing is just omitting a column that used to exist in this model. And when I click on pull request, what I expect will happen is that this will trigger this workflow that I was talking about before. Okay, here it is. So here I'm just going through the basic CI. So it's what I explained before. It doesn't do more than just like configuring the environment, creating a cluster based on the pull request in Materialize, and then doing a full dbt deployment. But what I wanted to show you, if Zoom allows me, is the workflow that this is running. Okay, it's called basic CI, and you can see here that it's a workflow that is supposed to run when a commit is pushed to any branch that is not main. And it starts by just configuring the environment, installing Poetry, having Poetry install our dependencies, including the dbt Materialize adapter. And then what it does is just call a dbt macro called create environment. And what this macro does is verify if a cluster with this name we generated already exists in Materialize. If it doesn't, then it just creates the cluster for us. And like I said, this is something that I see a lot of dbt Materialize users writing themselves. And our goal is to ship this kind of like utility macros in the adapter itself so that you don't have to write these things. And yeah, once this is passed, if everything goes well with the workflow, we should see, cool. You will see here that we did a full, dbt did like a full run of our project. It has 5 models and 1 test. And what I would expect to find now in Materialize is, I want to see our cluster for the PR. It's here. And I don't know in which database I'm in, but if I change to the staging database, I should see that the model I changed does not have the item name column anymore. So the workflow did what it was supposed to do. We have successfully deployed our dbt project to our staging environment, which means that without getting any further approvals, because this is a demo, I'll just merge my own pull requests, and this goes into the second part of deploying the actual changes to production. So again, I expect this to trigger a workflow here. So now this is running our CD workflow, which the end effect will be that this will make the deployment to production. If you're like in a real world company, you probably have like at least 3 different environments that things go through, but I hope you get the gist. And you will see here that because we're caching like all the dependencies, this workflow will go way faster because it doesn't have to munch through like all the poetry installation and all of that. It's all cached in GitHub. And the workflow that this is running now is the basic CD one. So we want to make sure that when a pull request is closed, either by being actually closed or by being merged, if it is merged, we want to go through the environment setup again. But what we wanted to do is run the reverse operation that we did before. So like we have the opposite macro that just goes and drops the cluster for our pull request to make sure that we like clean up after ourselves. And then we do exactly the same. We do a dbt build, which does dbt run, dbt test, dbt seed, like all these commands like bugged up in one. But this time we pointed at the production profile. So this ran and it's green. So again, we can check Materialize. My cluster that I saw here should be gone. And it's gone. And now I should see the exact same thing I saw above in the production database. So the column should also be gone. And you can see this is staging and this is production. So now we have like parity between the 2 environments. And one extra thing that this CD step does, and I will talk a bit more about it in a bit, but it is also uploading the manifest. It's uploading an artifact that dbt generates in every invocation to an S3 bucket. And we will need this next to not do a full dbt run every time. I will go into why you don't want to do that and how you can try to avoid that. Okay, let's go back to our slides. Cool. So what about state? One thing we need to be aware of working with dbt and any database, but in a different way in Materialize, is that every time you're doing a full dbt run, you're incurring the cost of redeploying your whole data model, which also means that you have to rehydrate potentially your whole pipeline. And I assume most of your pipelines do not look like this. So this might have more or less catastrophic consequences depending on the size of your DAG. So how can we minimize the blast radius here? So like, how can we make sure that we are not, if we make a change to a model in a sea of models, we don't rerun every single model in the project just for that little change. And here it helps to just take a step back and walk through all the work that happens behind the scenes when you actually do a dbt run. So like I just mentioned, the default behavior is to drop and recreate the models, but there's a lot more to it than just running your models. And something you might have noticed if you dabble into the target folder is that dbt generates and saves a bunch of artifacts every time you invoke it. And all these artifacts have really valuable metadata to power different things in dbt, like the documentation and what we're about to do next. And one particularly relevant artifact is what I just showed you a few minutes ago, and it's called a manifest. And what this file contains is just metadata of your last run. So what models and tests were defined, which ones ran successfully, which ones failed. And if you look at it, it's a big blob of JSON, but let me find it. But it has literally all the state of your data model in production. So you will find here like the raw, you'll find the create source statements, like all the DDL that is generated from the models to create your objects. Everything is in here. So this is a very valuable asset, and there are a lot of people in the community hacking the hell out of the manifest file. But it's going to be like very useful for us right now is because it contains the current state of your production environment. You can use it to compare it against the changes that you are submitting in these PRs. So with this, dbt will do you the favor of determining what is the minimum viable set of models that you need to run for a particular change that you make, instead of forcing you to run the whole project. And furthermore, a really cool thing that it can also do is it allows you to defer to production models. So for example, I'm gonna do something which in theory should fail when I run it. I hope it doesn't, because I tried it a couple of times and it didn't, but I'm going to go into staging and I'm going to drop my sources and everything that goes with them. Should I drop both? I don't know. I don't remember what I did before that worked, but I hope it does. Okay, so we are sourceless and basically anything less because I just cascaded everything. So staging right now is empty. And what I want to do next is change a model that is a little more risky. So I'll go for item purchases, which if you imagine this running in staging, it for sure depends on purchases as the source, which I just wiped out. And yeah, it also affects item summary 5 minutes. And you probably also need the items because there is a dependency here. So let me do something that I'm going to forget otherwise, which is I need to swap now from basic CI to our Slim CI workflow. Just before I forget. Cool, and so we can use this manifest file. We will be able to compare what's in production versus what is being changed in staging, but also we'll be able to read from production if we happen to not have the models in staging. And this is possible with two flags from dbt. One is called state. It's a state method and has a bunch like of operators that you can go to the docs and like take in because it's quite a lot. And then also like the defer flag. So what this looks like now is you can come up with a slimmer version of the previous workflows using these little tricks. And what will differ now is that we are just fetching the manifest from S3 every time we run these workflows. And we'll just do partial runs instead of munching through the whole dbt project every time. And this is like the overview of what the Slim CI looks like. And in the end, you can see that the major difference is that here you are fetching the manifest and then you are selecting only the models that have been changed and anything downstream from that, that's the plus. And you are deferring to production in case things don't exist in staging. And you are using the manifest to grab the state from production so that you can do like this reduced run that I was talking about. Okay, so now I will try to make it quick since we're almost at time, but I will change item summary. I will comment out a column name, items sold, and it affects 3 models. Cool, I just did this on my screen. I'm sorry, but let's see what we have here. So now we can just, okay, and then remove items sold. Again, we push it to our test branch. Okay, and again, we are removing 3 columns. If I missed something, this will probably fail. If pulverizing staging might also make this fail. But again, you see that now this is triggering a different workflow, this Slim CI workflow that I was telling you about, and how this differs if you look into the actual workflow. It's the same when you push a commit against the branch that is not made. You will go through the same things, install dbt, and the difference is here where you see that we will download the manifest from S3. And then you will again do the operation to create the environment in Materialize. And then you have like this huge, oh no, I'm running this with debug. The output is gonna be horrible, I'm sorry. So you have like this huge query where you're telling dbt to use the state that is trapped in this manifest and to defer to production for any models that don't exist. This hasn't run yet, so I'm getting nervous, but so yeah, I'm a little skeptical about like how this will look like just because I left the debug flag in there and it just spits out a lot of verbose stuff that makes it hard to see what's actually happening. But let's cross our fingers and see. If it turns green, I'm already like over the moon about it. Okay, no dbt packages. This is also like something that needs to run in case you're depending on some dbt package. We downloaded the manifest. see here, we're creating a new cluster for our pull request. And cool. I mean, you can see here that like we have 5 models in total and 1 test. And what is being run here is just 3 models and 1 test. So dbt used the state in the manifest to say, these are like the 3 things that you need to change, but you don't need to rerun the whole, the whole project. And if we actually had the verbose logs, it would be really cool to see. You would be able to see, I can show you in a past run. Cool. So you see that like dbt didn't run like all the models. It only ran 3 models and 1 test. But we can look at an older, I think this one that failed has what I want to show you, which is the part where dbt is in selecting from production, from staging, because the models don't exist in staging. So this is the debug flag. It's like if you run dbt -- debug run, you get like all of this stuff. But see here, like we are creating a view in staging, but we are reading from a production model. So I find this pretty cool. I'm pretty sure that this will not be this easy once we have RBAC in place, because then it will depend on like what role you have and what permissions you have. But I think this is like a really cool thing that dbt allows us to do, to not go through like our whole project every time. Cool, and that's about what I had to share with you. We have like some interesting and some exciting stuff coming down the pipe that will allow us to do maybe some things in different ways in here. So like the RBAC that I mentioned, we also really want to at some point support blue-green deployments. There's a lot of demand for that, but it's technically very complex. So yeah, we need to, it will take some time. But you know, we have all these ideas around also things that we want to enable in dbt. So like snapshots, but like materialized flavor of snapshots. So yeah, a lot of exciting things. And I hope this was useful for you. I had no idea until a couple of weeks ago about all these things and like all that's possible in CI/CD with dbt. So thank you. I'll take any and all questions right now. Andy, are you there? I'm
yeah,
bad at Zoom.
There was one question about, so is the inheriting from production, is it taking the view data, like, is it taking just the DDL statements from production, or is it actually also taking like the, if there's an index with data, it would be reading that from production as well?
Yeah, I think indexes are a really interesting thing that I don't really know what the behavior is, even though possibly I ran something that has an index in it. But I mean, because it's from a different cluster, I assume that like it will not be able to do anything with the indexes other than possibly just using them if it's querying the cluster. So if you look at here, for example, so like you only kind of like refer to the model, to the dependencies between your models using like this ref function. And what, as far as I understand, what dbt does is it knows that you have this item summary model in production. It just looks for that and just points it at whatever is in production. So it just swaps the reference from staging to what it has in the manifest.
That makes sense. And the views, any of the views are available across clusters, and so that's where it's transparent. Like there is no issue of being on a different cluster.
Yeah, I mean, that's the thing that might change with RBAC, or should change with RBAC, because not everyone should have access to everyone's stuff. But yeah, I think it's really cool, especially because at least when I was working as a data warehouse engineer, like one of really the biggest problems was just recreating the environment that you are deploying to in the end. So like QA and dev and staging were never like in sync with prod. It's like the data was not the same, the schema was not the same, the permissions were not the same. So it was just like a nightmare. But yeah, I'm curious to hear if anyone here tries this out or has used this before successfully. There's a really cool blog post from Ramp about how they are dealing with this, not using defer, but like rolling out their own defer. But yeah, if anyone is using it, I'd love to hear about it.
Chuck had a question. If the production cluster is using a materialized view, the staging models, would they take advantage of that?
Yeah, I mean, they could just read out of the materialized view without having to recreate the whole state to actually recreate the materialized view itself. So they can just directly read from the materialized view instead of running the chain of models that need to happen before that materialized view is created.
Yeah, that makes sense. Okay, I know people will probably have or be very interested in getting access to the repo with the code examples. So we will send that out as soon as possible, along with the recording here and some additional resources. Otherwise, if there are no questions, we can end there. And thanks for your time today, everyone.
Thank you.
All right, bye-bye.